Let's quickly look at these two triangles. Okay. Let me name this triangle TMN and I'll name this triangle XYZ. Okay. Let me give me some numbers for these triangles. Say this is of length 2, this is 4, this is say 10. Okay. And I'll call this one 4, 8 and this is 20. Okay. Now, let's find out what is this side divided by this side. I can see that there looks like there's some relation between these two triangles, and let's find out what that is. Let us find out what is TM divided by XY. TM is this length and it is given as 2. XY is this length and it is given as 4. 2 by 4 is 1 by 2. Similarly, let's find out what is MN divided by YZ. Okay. Let's find out what is MN divided by YZ. 10 divided by 20. This is also 1 by 2. Can you now quickly find out what the ratio of the third side is? As you find that out, we also observe that these two we are getting it as equal. Okay, we are getting TM divided by XY is equal to MN divided by YZ. So when we get two ratios as equal, then they are proportional. Okay. Now, coming back to the red side, Tn divided by XZ, I will get it as 4 divided by 8, which is also 1 by 2. So if I put together all of this, let me include one more here, Tn divided by XZ, I am getting that all the sides of the triangle are proportional, right? So then I can say that these two triangles are similar. Okay, that is, triangle TMN is similar to triangle. Now mind you, TM corresponds to XY, so I will write XY first. MN corresponds to YZ, so I will write YZ next. Okay, that's how you write it. These two triangles are similar. Whenever I get the sides to be proportional, or these ratios of the sides, if I'm getting it as equal, 1 by 2, 1 by 2, 1 by 2, or it could be anything, but as long as they're the same, say that these two triangles are similar. Okay. In class, I must have said that two triangles are said to be similar if their corresponding angles are equal. Okay. So let us now take a triangle in which all the three angles are given to be as equal. Okay. Let me draw two triangles where all the three angles are equal. That is, we have angle A is equal to angle D, angle B is equal to angle E, and then angle C is equal to angle F. Let's say that. Okay. Show that the sides are proportional. Okay. That is, AB divided by DE should be equal to AC divided by DF, and that should be equal to BC divided by EF. Okay. Remember, if you see that there's A and D here, then they are equal. There's B and E here, which are equal. A and D, they're equal. C and F are equal. B and E are equal. C and F are equal. Okay. Okay. So far we know that we have learned the basic proportionality theorem and the converse of basic proportionality theorem. That's the two things we know. And for that, in our breakdown, we need some parallel lines. so that we may be able to apply the BPT or converse of BPT. Those are the only two things we know. So let's make some construction. Okay. What I'm going to do is I'm going to draw a line. Let me call it PQ. Okay. Let's write down construct PQ such that, now how we construct it also, we will construct it such that DP will be equal to AB and AC should be equal to DQ. Okay, let me break it down. AB, C, and we will have DPQ. It is already given that in the problem that A is equal to D, and we have AB is equal to DP. This is by a construction, and the pink line AC will be equal to DQ. When I draw this single line, it means that this is equal to this. The single line over here, this entire line is equal to this line. Similarly, for double I use when there's another pair of equal lines. Okay. Alright. We can see that these two triangles look like they are congruent. Let's see how. We have AB in triangle ABC and triangle DPQ. AB is equal to DP by our construction. Angle A is equal to angle D, and we have AC is equal to DQ, and this is by our construction. The second one is given. It is given that these two angles are having equal, two triangles are having equal angles. Okay. So therefore, by the SAS congruence, triangle ABC, AB, so I have to write DP here, and then BC, so there will be PQ. Triangle ABC and DPQ are congruent to each other. Okay, that means this triangle and this triangle are exactly identical. Okay, by our congruency, we get that B is equal to angle P. Okay, by CPCT, I can get that angle B will be equal to angle P. Angle C will be equal to angle Q, right? B is equal to P and then C will be equal to Q. And this is by congruent parts of congruent triangles. Okay. Next step, let's see like where this could be useful. So we got that this angle is equal to this angle and this angle is equal to this angle. But we already know that B is equal to E and C is equal to F. But by CPCT, we got B is equal to P and C is equal to Q. Okay. And Q is here and P is here. Okay. Why we did this? We constructed PQ here such that this side will be equal to this side and this side will be equal to this side. After that, we found out that this pink triangle is actually equal to this pink triangle over here. And then after that, by CPCT, we got that this angle will be equal to this angle is equal to this angle. Okay. We got this as similar, congruent. Now, let us only focus on triangle DEF, the triangle that is colored in yellow. Let's focus on this triangle now. Okay. we got that this angle is equal to this angle, which means that if I had two lines and a line this way, we don't know whether it's parallel or not, but if this angle is equal to this angle, then say I'll call this line M, I'll call this line M. If this angle is equal to this angle, then L is parallel to M. It's called corresponding angles. So if I have two lines and their corresponding angles are equal, then the two lines are parallel. Okay. Now because this is equal to this, if you see that if I extend this line here, extend this line, it looks similar to this, right? And I got this angle equal to this angle, just like this angle equal to this angle. So this line has to be parallel to this. This implies PQ is parallel to EF. Let us bring down that triangle. Over here. Okay. Now I have a triangle which has parallel lines. We are having PQ parallel to EF. So let us apply BPT. By BPT, we get DP divided by PE is equal to DQ divided by QF. By basic proportionality theorem, we got DP by PE will be equal to DQ by QF. Let me write this way, PE by DP. Let me invert this and I'll do the same thing as well over here. QF divided by DQ. And I got QF divided by DQ. Let me add 1 on both sides. On both sides. Okay, now we will have to take LCM. The LCM of DP and 1 is DP itself. So I will get PE plus D. This is PE by DP, DP by DP, QF divided by DQ plus DQ by DQ. Now, let us quickly see what is. Let us write this PE plus DP. Since we have a common LCM, I can write DP in the denominator. QF plus DQ with DQ as a common denominator. Okay. This then gives me, let's find out what is PE plus DP, shall we? This is PE, this is DP. So this entire green line, it is called DE. By DP, and we got DQ and plus QF. We have QF plus DQ, which is DF. DQ. Okay. But from up here, 1, I know that AB is equal to DP. So in the place of DP, I'm going to put AB from 1. And DQ from above here, I know it is equal to AC. So I will put that down here. And let me invert on both sides. Because what I require is AB divided by DE. But what I have here is DE divided by AB. So I can very well invert this and write. I can turn it around. AB divided by DE. And here I can write AC divided by DQ. Okay. And I got one part of the proof. I got this part. AB by DE, AC by DF. AB by DE, AC by DF. I'm sorry, I made a mistake. I wrote DP instead of DF. It is DF. Okay, all right. A quick recap of what we did. We first had these two triangles, then we constructed a line PQ, we made a construction. Remember to draw all your construction in dotted lines, and we found out that because of this construction, these two triangles that I'm getting are actually congruent to each other, which means this angle and this angle will be equal. So these two lines will be parallel, and because they are parallel, I can apply BPT theorem, and by applying BPT theorem and using the congruent parts of congruent triangles, I am getting this part. Similarly, if I want to do this part, I will draw a line that is, again I will do one more line like exactly like PQ. I can make a line, say RS, and then I can repeat the same whole process. I can rotate this triangle, and then this time I'll have these two lines which are parallel and do the same process again. Okay, I hope this video made a little sense. If you understood some parts, I would like you all to try writing the proof for it. You have to basically write down the constructions, the breakdown into a proof format. Okay, you can pause the video at any point and see for reference. Okay, that's how you do the AA criteria. Remember some things. You have a construction, then you have congruence. After congruence, you have BPT to apply, and then you have some algebra to do. The add one on both sides. Okay. So I want you to write the proof 2 times in your notebook. Okay. This is a very important proof. Thank you for watching.